Hi everyone, welcome back to my number sense series. In this video, we're going to continue our talk about geometry, this time talking about rhombuses and squares. Now, if you already know a little bit about this topic, you might be a little bit confused at the title. First of all, why did I say rhombuses when the plural of rhombus is rhombi? Well, rhombi sounds kind of weird to me, so I'm going to say rhombuses, which I think is also grammatically correct, kind of. Also, squares are a kind of rhombus, so why did I say rhombuses and squares? Well, the fact of the matter is squares are so special that there's a bunch of special properties that most rhombuses don't have. And the fact that they have a separate name, they're called squares and not just equal, like 90-degree rhombi, that should tell you enough about the uniqueness of squares. Now, to understand what a square is, we should understand what a rhombus is. And a rhombus is like a parallelogram. Think of something like this, where two sets of sides are parallel, but all of the sides are the same length. And that leads to a rhombus looking something like this. But often I prefer to draw it like this, just so we can make it more obvious what's going on. Now, a rhombus has some very interesting properties, and most of them relate to its diagonals. If we draw these two lines, hopefully my geometric representation is good enough for you to tell kind of what's going on. Because when I draw these two lines, the diagonals, something very interesting happens. Two things. First of all, they create right angles. Everywhere these two meet, it's right angles, 4 right angles. And also, what happens is that these two diagonals bisect each other. They cut each other in half. And so you can see these pairs of equal side lengths happening here. And this is very nice things for rhombuses because first of all, you can have the Pythagorean theorem be applied with right triangles, and also you can calculate the area very easily, which is what our first problem is about. Given the area of a rhombus with diagonals 50 and 64, what is it? So, to find the area, let's make a drawing. If the diagonals are of length 50 and 64, it might be easier to draw them in the bisected form. So in other words, this entire thing is 50, and this entire thing is 64, but here we can write 25, 25, 32, 32, to make it a little bit easier to understand what's going on. Now, how can we find the area of this rhombus? There's a few ways to think about it, because there's a lot of triangles created here. You have this triangle up here, you have this triangle on the side, and you have this right triangle, which is made 4 times. So you can think of the area in a lot of ways, but I'm going to think about it using a right triangle, because that also leads well into our discussion of the Pythagorean theorem. So using this right triangle, what is its area? Well, its area is going to be the 2 legs multiplied divided by 2. In other words, 25 times 32 divided by 2. But in the entire rhombus, there are 4 of these right triangles. So if we multiply by 4, what we get is 25 times 32 times 2. Now, 25 times 32, we have a trick for doing that. 32 divided by 4 is 8, so it's 800. 800 times 2 is going to be equal to 1,600. So that's the area of this rhombus. But I don't want to have to do all of this every time I try to find the area of a rhombus. I want to find a formula based on just the diagonals. And how can I do that when my final calculation didn't involve the diagonals? Well, it kind of did, because 25 is 50 divided by 2, and 32 is 64 divided by 2. So basically, our area should be diagonal 1 divided by 2 times diagonal 2 divided by 2 times 2, which in total is equal to diagonal 1 times diagonal 2 divided by 2. It's a little bit just like base times height over 2, just with diagonals. And this is how we find the area of any rhombus. Now, of course, the area isn't the only nice thing, because here we also create right triangles. And whenever we see right triangles, anytime you see right triangles, you should think Pythagorean theorem, which is what our next problem is about. Because here we have a rhombus with diagonals 6 and 8. So let's draw that out. And once again, if it has length 6 and 8, we can tell the legs of our right triangle, because the legs are just going to be the diagonals cut in half. So if one leg is length 6, then if one diagonal is length 6, then one leg would be length 3. And if the other diagonal is length 8, then the other leg would be length 4. And here we should immediately recognize the legs are 3 and 4. What does that say about the hypotenuse? 5. It's a 3, 4, 5 right triangle. Memorize your Pythagorean triples. This is the most important one, the 3, 4, 5. And now, since we have 5, 5 is not only the hypotenuse, but also the side length of the rhombus. And remember, it's a rhombus, so all the sides are the same. So our perimeter is just going to be 5 times 4, which is 20. Now, similarly, we have that the area of a rhombus is 120 and one diagonal has length 24. And now they want us to find the perimeter. So this is kind of combining these two problems behind me. Here, when you see the area of a rhombus and one diagonal, you should immediately think about what's the other diagonal, because the area is made by finding the two diagonals, multiplying them together and dividing by 2. So if I have one area, and if I have one diagonal, I should be able to find the other diagonal. So the area is 120 equals 24 times the other diagonal, I'll call it D, divided by 2. Now here, how I can solve for D is just saying 24 divided by 2 is 12. If I divide both sides by 12, I get D equals 10. But I'm not out of the woods yet, because I actually want the perimeter. And here is where I have to draw the right triangles. So if I draw this out, hopefully you should be able to picture what the right triangle looks like, because it's just a right triangle where the legs are half the diagonals. So it actually looks like a right triangle where one leg is 10 divided by 2, which is 5, and one leg is 24 divided by 2, which is 12. And I'll draw it out here for reference. It would look something like this: 5, 5, 12, 12. Ignore the horrible drawing. This is what it would look like. Basically, you have 10, 24, and they're each cut in half. So we're focusing on basically this right triangle right here, 5 and 12. Now, once again, when you see legs of length 5 and 12, what you should automatically think about is a 5, 12, 13 right triangle. Another, what I would say is the second most common right triangle, 5, 12, 13. And here, once again, we can find the hypotenuse. The hypotenuse is 13, which is also the side length of the rhombus. So you get the perimeter of the rhombus, we just multiply the side length by 4. So it's 13 times 4, which is 52. And that's the hardest part of the video out of the way, because now we move on to squares. And squares are even nicer than rhombuses, because squares are so unique. The rhombus is where all the angles are 90 degrees. So it's much easier. For example, they might ask us to find the length of the diagonal of a square with side length 50. And here's where we have to invoke something that we talked about a few videos ago, the 45, 45, 90 triangle. Recall that the 45, 45, 90 triangle is an isosceles right triangle, where you have 45, you have 45, so those are 2 degrees, and you have 90, making it a right triangle, and the side ratios are 1, 1, and square root 2. That's the important part. Because when we draw a diagonal in a square, it actually creates an isosceles right triangle. It creates this 45, 45, 90 right triangle. And so the side ratios are going to be 1, 1, and root 2. So it's going to be 50, 50, and 50 root 2. Same ratio. And that's it. That's literally it. The length of the diagonal is square root 2 times the side length. Of course, if you ever forget, you can always derive this using the Pythagorean theorem. Now finally, the area of a square with a diagonal length 52 is what? And here, it doesn't look like they give you a lot of information. Now, if I've never seen this problem before, if I've never done number sense before, and I've seen this problem, what I'm going to think of is the area of a square is its side length squared. And I want to find the side length, and I could find the side length if I wanted using this right triangle. In fact, the side length would be 26 times the square root of 2, and then I would square that. But that is not how I would do this question. Because recognize, a square, as I said, is a rhombus. A square is a rhombus, and so the area formula works the same. It's diagonal 1 times diagonal 2 divided by 2. But wait a second, they only gave me one diagonal. Well, yeah, because the diagonals are of the same length. Remember, it's a square, and it's really, really nice. These two diagonals are going to be the same length. It's, if you think about it another way, the same right triangle. So if the diagonals are the same length, all that means is my area is 52 times 52 divided by 2. Now, final thing, when it comes to this calculation, you could think of it a few ways. You might want to think of it as 26 times 26 times 2. If you know your squares, 26 squared is 676, and multiplying that by 2 would give you 1352, which is our answer. But I would also like to remember our other trick with squaring numbers from 40 to 60. We can square 52 in our heads very easily. Here's how it goes. 52 is 2 more than 50. Okay, remember that number, 2. So 52 squared is 25 plus 2 equals 27. Then what's 2 squared? It's 4. 4 divided by 2, which is going to be 1352. Same answer. So you see, these square problems are really just like the rhombus problems, just way easier, because again, a square is a special rhombus. So this is what we do with rhombi, or rhombuses. Remember, the most important thing to remember about rhombuses is to do with their diagonals. When you draw their diagonals, not only do they make right angles, but they also bisect each other. They cut each other in half, and that's what allows you to make, nice right triangles. That's what allows you to make a nice area formula. So if you take away anything from this video, let it be that the diagonals bisect each other and create right triangles. The area formula is diagonal 1 times diagonal 2 over 2, and a square is 2 isosceles right triangles put together, and that is really about it for this video. The rest is about applying these formulas, applying these ideas, these right triangles, the Pythagorean theorems, and using them in actual questions to get experience. So I hope this was helpful to you guys. Thank you guys so much for watching, and I'll see you next time.